In this video, we will be simplifying expressions with exponents. So the question we have here, the example we have here, is x to the power of 0, parentheses, y to the power of 2, parentheses, to the power of negative 3, z to the power of negative 5, divided by x to the power of 5, y to the power of 4, and z to the power of 7. So if we look at our exponent rules right over here, we can see that this would best represent this scenario. So n is the exponent in our denominator and m is the exponent in our numerator. So if n is greater than m, meaning if our denominator, the exponent in our denominator, is greater than the exponent in our numerator, we would be applying this rule. In this scenario, we can see that all of our exponents in our denominator are greater than our exponents in our numerator. So we will be focusing primarily on rule number 5. So this rule is stating that in order to simplify, we will have 1 is our numerator, and then we'll subtract m from n, and that'll be our exponent for a. First, we will start with x to the power of 0 and x to the power of 5. So our m is the exponent in our numerator, which is 0. Our n is the exponent in our denominator, which is 5. So 5 is obviously greater than 0, meaning that we're going to apply rule 5 as stated before. So now we have our 1 as our numerator already, which is what we want. Then we're going to do 5 minus 0. 5 minus 0 is 5, meaning that x will still be to the 5th power. So we're just getting rid of this. Next thing we have to do is our y to the power of 2, which is also to the power of 3, negative 3. We can see that rule number 3 explains how to do this part. It's stating that if there is a coefficient or a variable, a, and it's to the power of, let's just say, m, and that's in parentheses, and there's another exponent right outside the parentheses, that m, the exponent in the parentheses, and n, the exponent outside of the parentheses, would be multiplied, and that would become the exponent for a. In this scenario, our a is y. In this scenario, our m is 2. And in this scenario, our n is negative 3. So by following rule number 3, we're going to do 2 times negative 3, which is negative 6. So now we have negative 6, which is going to be in our numerator. So we have y to the power of negative 6. And that's over y to the 4th. We're just ignoring all the x's and z's right now. We're just focusing on y. So here, we know that 4 is greater than negative 6, right? So in this scenario, we're going to still follow rule number 5. So we have our n as being 4. That's going to be subtracting negative 6. 4 subtracting negative 6 essentially means 4 plus 6, because 4 minus 6, the two minuses make a plus. 4 plus 6 equals 10. So we have y to the 10th. And again, we should have another 1 here, all right? It'd be 1 times 1, but 1 times 1 is just 1. So for the sake of simplicity, I'll leave all the 1's up there, and in our final answer, I'll simplify it all down. So we have our x value done, we have our y value done. So that's crossed out, that's crossed out. Now, we're going to focus on our z's. Again, we should see if z satisfies rule number 5. If n is greater than m is our numerator, n is our denominator, 7 is greater than negative 5, and we can write that down here. 7 is greater than negative 5, meaning, well, first, let's do this. So we know 7 was in our denominator, right? And our denominator is represented by n, the exponent in our denominator. Negative 5 was in our numerator, and the exponent in the numerator is represented by m. So if n is greater than m, we would use rule number 5. So we're going to have another 1 here, right? Because we are still following 5. But now we have our n, right? N minus m, 7 minus negative 5 equals 12, right? Because it's just 7. It's just 7 plus 5, which is 12. So that means z is to the power of 12. This all gets simplified down to 1 times 1 times 1, right? In our numerator, 1 times 1 times 1 is just 1. And our denominator stays the same as x to the 5th, y to the 10th, and z to the 12th. I hope this video helped, and please let me know if you have any more requests.